Hello, it's James from XRobots.co.uk. This is part 27 of Ultron, the Real Robot. The aim of this series is to build Ultron as a real robot driven by its own AI, which is going to be remote and connected by Bluetooth. And last time we had a go at some brain building, which is going to be driven by Arduinos. It's got lots of nice lights in it and its own animatronic sort of finger tentacle things, so it can reflect how it's feeling in real time as it tracks emotions. And we're going to be doing some more work on that today. In the past, we fitted mood lighting into Ultron. We've also put feedback in its joints so it can tell where it's being touched. We've got some rudimentary vision detection and motion tracking built in. And today we're going to go and have a look at putting some speech into Ultron. There will be other sensors as well, including hearing and various things. And all those will get integrated into the AI so that it can act like it's hopefully a real person and be very socially interactive. It's also going to be partly driven by a motion capture suit, so it's quite an involved project. Have a look back on the previous parts of the mechanics, but let's have a look how we're going to do the speech. Right, what I've got here is the Parallax Emic2 Speech module, which is a fairly fully featured speech module that takes text from your Arduino sketch, and I've got one linked to it here, and turns it into speech, and it does different pitch and different speaking sounds and all sorts of things. So I've got the self-test hooked up here. I've got some USB speakers, so let's see what the self-test does.
Hello. My name is the Emic2 text-to-speech module. I would like to sing you a song. Daisy, Daisy, give me your answer too. I am half crazy, all for the love of you. It won't be a stylish marriage. I can't afford a carriage. But you'd look sweet upon the seat of a bicycle built for two.
There's lots of good documentation for this module. This is the PDF manual, which is free to download. Emic2, there we go, speech to text module. So it does various things. There's a picture of it here, of course. The wiring diagram, so it's got serial in and serial out. Basically a speaker out as well as a line out, and takes 5 volts and ground. So if we scroll down here a bit, there's a command set, so you basically send a letter followed by something, whether it's a number for one of the parameters or some text that you want to speak. So there's an Arduino sketch that comes with it, which is pretty good, so let's have a look at that. The sketch is using software serial, which I don't really like because it's slower than hardware serial, and I have spare UARTs on my Megas which are running the brain, so I'm going to switch that over to hardware serial eventually. But for now it's using a software serial at 9600 board. It also has an LED on the Arduino, it turns on and off when it's ready. So basically it initializes here by sending a carriage return. The module will return a colon when it's ready for speaking, and you can do that in between speaking as well. So we've got some default settings here. 200 words a minute. This is the first voice, and this is US English. It does Spanish as well and does 8 different voices. So obviously the first part we can see in that demo is the letter S to speak, followed by a string of characters, followed by a carriage return, and when it's finished it returns a colon, and then it moves on to the next part. So one of the self-tests here is doing the singing. It has 3 self-tests, speaking, singing and Spanish speaking, and that's already built into the module. So that's the code for all of that thing there. The most important part of course here is the string of text and these parameters, and we can make it go pitch up, pitch down, and various different voices, which is quite good for the singing and various other things about expression in the voice. So I'm going to change some of these. The voice isn't particularly Ultron-like. If we refer to the manual, there are other voices, so I'm going to change it to one of the others. The one I want to use in the end is Huge Harry, because that is quite a gruffer voice. But let's try one of the others. Let's try Beautiful Betty and see how that sounds. And for now I'm commenting out the singing because that always does a default voice, so we'll take that away and we'll just get the text to be spoken. So let's change that to voice number 2 and see how that sounds.
Hello, my name is the Emic2 text-to-speech module. I would like to sing you a song.
So you can see how that works, but what we need is an Ultron voice, so I'm going to change this now to 1, which is Huge Harry, and I'm going to change this to 180 words a minute, so it's a bit slower.
Hello, my name is the Emic2 text-to-speech module. I would like to sing you a song.
I decided I wanted it to sound even more like Ultron, so I got out some of my old home recording gear. I've got a Line 6 Pod Pro here, which is really a guitar processor, but it's got lots of effects, so I've wired that speech module through this processor. And now if I trigger the sounds...
Hello, my name is Emic2 Speech module.
And I can put
I
reverb
would
on
like to sing you a song.
and things like that, but that's not particularly Ultron sounding, and I think the effect that we want here is probably flanger. There's a couple of options.
Hello, my name is Emic2 Speech module.
It's a bit
I
excessive,
would like to sing you a song.
but that's basically a kind of metallic sound. Let's listen to the other one. It's that metallic reverb we want, really.
Hello, my name is Emic2 Speech module. I would like to sing you a song.
So it sounds very metally, which is kind of like Ultron. Let's just turn down that effect slightly.
Hello, my name is Emic2 Speech module. I would like to sing you a song.
And we can give it a bit of reverb, perhaps.
Hello, my name is Emic2 Speech module. I would like to sing you a song.
Maybe slightly less.
Hello, my name is Emic2 Speech module. I would like to sing you a song.
So it's kind of a bit like Ultron, and as I say, we can put more expression in its voice by altering pitch and altering speed as we go. So after a bit more messing around on a better quote...
I'm gonna show you something beautiful. People screaming for mercy.
So not sounding too inspired about people screaming in mercy there, but I guess that's the best we can get out of a speech synth without going and writing every word phonetically to give it emphasis and so on. We can put emphasis on some of the words, but it means modifying every sentence, so we'll see how that goes and how much it has to say. So all we really need, of course, is this processor. It's a bit big really for flanger. You can get a guitar pedal, which I may do. For now I'm going to leave myself an audio out from my Emic module and an audio back into the brain so that basically I can use whatever audio processing I want separately. In order to get the audio back over to the robot, I'm going to use this Bluetooth transmitter that turns any audio source into basically a Bluetooth device, and it will transmit over to a Bluetooth speaker which it will automatically pair with. I'm waiting for a loud Bluetooth speaker to arrive to fit inside Ultron, but that means I can fit my speech module and any other sound effects inside the brain, pipe them through audio processing into this and send it over to the robot. Right, my Bluetooth speaker arrived, so now I've got my little device here plugged in the output of the audio processor. This thing's plugged in again, and if I reset the Arduino...
I'm gonna show you something beautiful. People screaming for mercy.
That's completely wireless. We'll just pop that there for now.
I'm gonna show you something beautiful. People screaming for mercy.
I'm going to need a better place to put this, but first of all we need to hack the speaker so that I can synchronise the jaw movements. So our choices are reading the text for each sentence and syncing up jaw motions and sending that jaw data over Bluetooth to the robot like the other axis. Or we could read the analog audio out of this speech synth and then try and sync up to that, we're looking for peaks and so on, and send that data over Bluetooth. What we're actually going to do is read the audio at the Bluetooth speaker ends and stick that straight into the jaw. So we're again going to read an analog in from the inside of this speaker, and that way I can make it very fast. So if I have to read it at this end and transmit it, we've obviously got that delay of the loops running and sending serial data. Instead what we'll do is just send a flag to turn it on and off. So if we send other sound effects, its jaw doesn't move. So we're going to hack this speaker and find some sort of audio out that we can read with an analog in of an Arduino. So I've taken the grill and the front panel off, and we can see there's just two speakers in there and one board there. So let's just have a closer look at that. It appears to have a microphone on, so I'm assuming you can use this as a comms device. And it's got the battery there and one wire for power and two for speaker out. So let's have a closer look at that board. So this is a much smaller thing than it was when it was in that massive case, mainly because there was lots of air in there. Obviously I could put any speakers on there, and I need to now find a line out so that I could in fact put any amp on or another pair of amp and speakers. There is a socket here, but that's an aux in unfortunately. So I'm just playing some audio off my phone here connected to these Bluetooth speakers. I've grounded my other pair of speakers here, the active speakers, with this crocodile clip to a ground pin. And now I can use the end here to probe around, and I think I've found some sort of audio. It seems to be audio anyway. If I do this, then I get the same sound through my other speakers. And it looks like there's two amp chips, one on the top and one on the bottom. So probing around those pins seems to be the right place to find the audio. Right, I've just soldered a wire onto those connections and we've stuck those into the analog in of an Arduino, so we can now read that analog signal and see what we get from that. Right, so I've just written a really simple sketch there with a variable called audio. It's got serial set up and the analog input, and basically all it's doing is reading it and writing that audio out. So now if we use the serial plotter, we can see that we should have some values, and this is just sort of background noise. Pretty low values. I'm not quite sure what level the line out is coming out, whether that's actually one of the speaker outs, but there's somewhere there on the scale. So we're talking about somewhere less than 250 out of a maximum of 1023. So I'm now going to reset the Arduino and we'll play some audio and see what happens.
I'm gonna show you something beautiful. People screaming for mercy.
So we can see the peak is changing there up to about 600 each time we do that. Let's just do it again.
I'm gonna show you something beautiful.
So we're getting much bigger values, and what we should be able to do is filter those out by just putting a threshold in and using that to activate the jaw servo. Well, I've just made a small modification to the sketch by having pin 13 declared as an output here, and that's the onboard LED on that receiving Arduino. So I've just said if the value is more than 400, turn it on, otherwise turn it off. So now if we press the button, we should see that LED flashing in time to the sound almost.
I'm gonna show you something beautiful. People screaming for mercy.
So that seems to work pretty well. Now we just need to turn that into a servo motion. Right, I've now just set up a little servo here, and I've put a threshold on and a delay to how much it stays in each position so it's not too jittery. So now if we play the sound again,
I'm gonna show you something beautiful. People screaming for mercy.
so it's not too bad, and of course I can adjust the level of the output, so let's just do that again.
I'm gonna show you something beautiful. People screaming for mercy.
So it works not too badly. We'll have to see how that looks on Ultron's jaw, and of course this Arduino and this servo are just for testing. We already have an Arduino and a servo in Ultron's head already.
I'm gonna show you something beautiful. People screaming for mercy.
So it's not totally perfect, but it's pretty good. There's a bit of jaw jitter that shouldn't be there. If I turn down the reverb on the audio processing, then it's a lot tighter, but we don't get such a good voice. And also if we up and down the level on the audio processing, we can affect how sensitive it is. So actually I don't need to change any parameters on the code to make it more or less sensitive. I can just make it louder or not as loud. That seems to work okay. So the brain is actually sitting down at the other end, still controlling anything, along with the audio processing and the speech. So my vision tracking should still work. Yeah, there we go. If I hold up this yellow thing, seems to work pretty well. But now we need to integrate the speech so it's reactive along with the sensing that we put in before. So for now that Bluetooth speaker module is just floating around here in the front of the chest, and I've got a speaker either side. I'll probably fix it in permanently there, give some proper power to this rather than the battery it's still running on, and I might even put bigger speakers in the base with another amp so it's loud enough for events. I've installed that speech module in the base of my brain down there. It's just on a piece of breadboard for now with some wires soldered to pin strips, and it's attached to the Arduino there that deals with the reflexes. So I've programmed up Ultron so now when it sees the object it now tells you, and when it can't see it, it tells you as well. So if I hold up this blue item that I've trained it for,
There it is.
he says there it is, and it should still track it. And if I take it out of vision,
Where did it go?
he says where did it go? Right, it's time to put some more stuff into our brain. I really want some sort of LED cluster that will reflect when it senses something. So when it's touched, when it hears something eventually, or when it sees something. So we're going to build a nice LED cluster here with a kind of cord that comes off the back that looks like a piece of a bionic brain. And we're going to have some LEDs on, and we'll program those up on our main Arduino that deals with the reflexes. I'm going to make a thing that looks like this, so it's going to sit back at an angle and have concentric rings that are all spaced like so. Each one of these is going to have LEDs in it. I'm going to use normal 5mm LEDs for reasons that I'll come on to. So there's a number of LEDs in each one that will flash various patterns linked to the Arduino Mega. So let's get that printed and soldered up. Here they come. Right, here it is all assembled. I've solvent welded those pieces together, and that's going to sit back in the brain just here. And I'm going to use these normal 5mm LEDs inserted on the holes wired up, so they're just normal LEDs. I'm not using neopixels for this part because, as I mentioned last time, they affect all the interrupts and timers on the Arduino, and the Arduino that deals with this is quite critical because it deals with the input and output and all of the timing and all of the motion smoothing. Right, I've wired all the cathodes, the negative pins on the LEDs together, and I've wired resistors to every single one of the anodes, the positive pins, and that means I can individually address these LEDs. I might group some of them up. There's quite a lot of digital I/O on the Arduino Mega, so we'll see how it goes. Right, I've wired loads of wires in here, and these all come across to this Arduino Mega. This is just a test Arduino at the moment. Obviously there's one in the brain to use, and I've wired it into loads of the digital pins here. So now we can program some sort of pattern to run on this when various things are triggered. So the LED array isn't, the pins aren't assigned in logical order, so the pins that the outer ring there is assigned are to 35 through 53. Some of them aren't in even ascending order, they're in a sort of a random order where I've soldered them on. So I've put all of these into an array here called LE pins outer. There'll be one of these eventually for each of those rings. I also need to multitask this code so that basically it doesn't affect the motion of the robot, so I can't use delays in that pattern. I have to keep my loop running all the time. So if you look at the Adafruit multitasking tutorials, you'll find very similar things to this. So we've defined a thing here called previous millis, and we're using millis in our loop here, which basically counts the amount of time that's passed since the system booted. So first of all, we've got some flags and things, we'll talk about that later, but in our setup we basically count through the array, setting all of those pins with a for loop to output, and setup only runs once when you turn this on or reboot the Arduino, so that sets all the pins as output pins, only does that for loop once. I've also set an input pin here to trigger it to demo this. Eventually this will be triggered by senses getting triggered, like the sight and the touch and so on. So in our main loop here we're resetting a variable called current millis to millis, which resets it to the current time. And then we've got two if statements, and they both check the time to see if some time has elapsed between the current time and the previous time, which we set on each of these. And if it's more than the on time, which we've set up here to be 30 milliseconds, and some flags are set, then one of them will turn the relevant pin on and the other one will turn it off. When it's turned off, it's also incremented, so P+1 brings it onto the next pin in the array. So basically it will scroll through the whole array. When it gets to the end of the array, if it's more than 10, it sets it back to the beginning again. But it only does that if the trigger pin, or the trigger variable, is set to 0. And that trigger variable is set by digital read on pin 8 at the moment. So if I ground pin 8, it makes the pattern run. We've got flag 1 here, which basically means that this if statement will only run if the flag is 0, and when it's run it sets it to 1, so then this one will run when the time is up the next time, and that sets it back to 0, and of course 1 turns the LED on and 1 turns it off. So this whole loop keeps running, there's no delays in here, and this will be integrated into the main loop for that input-output Arduino that deals with the speech, the motion and everything like that, so it doesn't consume any time and hang up the motion. So now if I ground pin 8, we should see that pattern run. There it goes, and it will basically freeze if I unground pin 8 and start again if I ground it again. So essentially whenever I set that trigger variable to 0, it will allow this to run, and when I stop it will stop and have stopped counting. So let's just try that. So depending on where you let go, sometimes it catches it on the on and sometimes it catches it on the off, but obviously you can see the pattern is sort of frozen in time there. So sometimes you end up with one LED on, and other times they're all off because you've caught it on this low section. So now I just need to write that for all 3 of those rings and integrate it into the main code. Alright, so I've now attached my little sensor indicator thing to the brain here. I've put a bit of this spiral binding on the cables because it looks a bit organic, it's slightly translucent. I'm going to have more widgets like this fixed throughout the brain, you see, for different things as we build out the modules. So there's plenty of space in there. And so you can see my multitasking code is running for the actual brain because we've got all these LEDs that will eventually track emotions changing colour in the background. So now if I just ground those pins, there's my outer array, that's the next one in, and then that's currently the 2 middle ones, and if I manage to bridge across 2, we should be able to get all of them to run. And the outside, and it'd be good to put a diffuser on this so that we can actually diffuse the light. I was thinking about a clear Ninja Flex thing, because it's quite translucent, a bit like this stuff, and we can have more sort of bio-organic looking stuff in there. So now instead of triggering this from pins, I need to code this up so when it sees something, one ring shoots round, and so on. And obviously we can have different effects. We could break this down into smaller modules because it's only code. I could have, of course, had different coloured LEDs, but there we go. Right, so I've now programmed that thing to react. So one of the circles reacts when I touch Ultron, so let's just hit him there. So we should find this inner circle flashes round. It does it for about 2.5 seconds and stops. And at the moment that's just triggered on any of those force sensitive resistors in the joints. There we go. And the other one on the outer ring there is triggered by vision. So now if I hold up the yellow thing, we should see that flashing round when there's vision. And of course moving the head is actually wobbling the whole body, which is why we're seeing the inner ring moving as well when the head is moving. So I need to tune up the sensitivity on there. Alright, but that seems to work pretty well, and of course we could have different patterns on here so that perhaps if there's more stimulus it goes faster, or there's some other pattern. Alright, that's all for this time. Next time I'm going to be looking again at the series elastic actuators, those force sensitive resistors in the joints, trying to pack those out mechanically so we can get better sensitivity, and doing some more work on the brain to make Ultron respond to touch, and looking at some of those emotion tracking things in the brain we talked about last time. So don't forget to subscribe for more updates on this project and other projects. You should also check out the links in the description for my t-shirt store. I have various merchandise for sale, and I have one limited edition design that's going to disappear at the end of January 2017. So you've not got long to get that one. And also, if you'd like to fund me on Patreon, have a look at patreon.com/XRobots, where you can get access to some exclusive rewards, including a live broadcast with me and all my videos early. Alright, that's all for now.